Okay, in this video I'm going to talk about even and odd functions. Even and odd functions. Okay. So first of all, we are going to say that a function f, any function f, is even, we call it even or described as even, on this interval, which is from minus L to L, if its graph on minus L to 0 is the reflection across the vertical axis of the graph on the interval from 0 to L. What is the meaning of this? Let's look to this figure here, figure 13.8. This is a typical even function. Look to this function. You can't tell easily that there is this function is like a mirror on this vertical axis, right? So this is like a mirror on the vertical axis. So, and this is the meaning here when we are dealing or when we are defining it, that we are telling, if we are talking about a function from minus L to L, okay, this means that 0 is going to be in the middle, okay, and this part of the function or the graph is the reflection across the vertical axis of the graph on 0 to L. So this is an even function. This is an even function. Okay. This happens when f of minus x, this is here, any point here, this is f of minus x, okay, equal to f of x, and this is right. Okay, so this is f of x here, and this is f of minus x, right? Here this is minus x, for example, here this is x. So we are having the same value for x between 0 and less than or equal to L. This is right. For any point on this part, if it has another value that is like reflected on the vertical axis, then we are saying that this is an even function. For example, x to the power 2n, x to the power 2n. For example, if we say that x to the power 2, okay, x to the power n, it is an integer, okay. So for example, x to the power 2, x to the power 4, something like this. So we're going to find that it is going to be like even function reflected on the vertical axis. Another famous example is this, which is the cosine. For example, cosine n pi x over L. This is a very common even function, which is the cosine function, okay, or even on any minus L to L for any positive integer n, okay, for any positive integer. And so if we remove this n and put any positive integer, then it is going to be even, okay, positive integer 1, 2, 3, 4, 5, 6, and so on. Okay, so this is our case. Okay, now let's go to another type, which is when the function, we call it f is odd function. Okay, let's clean here. Okay, if a function f is odd on the interval minus L to L, if the graph on minus L to 0 is the reflection through the origin of the graph on 0 to L. What is the meaning of this? Look to this function here. This is the origin here, and this part of the graph, it is reflected on the origin, okay. It is not reflected on the vertical axis, it is reflected on the origin. Okay, so this means that any part here on the right of the origin, you are going to find another part, but it's a negative value, okay, through the origin. This means that f is odd when f of minus x equal to minus f of x, and this is right. This is very right, very true. For example, this example, let's assume it equals 40, but here we're going to find the same. If we say this is minus x and we say this is x, x gives us 40, for example, f of x is 40 here, but f of minus x, it is exactly minus 40. So this means that f of minus x equal to minus f of x for x between 0 and L and equal to L. For example, one of the famous odd function is x to the power 2n plus 1. Okay, x to the power 2n plus 1 for n equal to any positive integer. Okay, 1, 2, 3, 4, something like this. Okay, and another famous odd function is going to be sine n pi x over L. It is considered also to be an odd function on the interval minus L to L for any positive integer n. For any positive integer n. Okay. Okay, now we understood what is the meaning of even function, what is the meaning of odd function. Okay. Now let's go and give a additional piece of information regarding odd and even. Whenever we have a product of two even function, okay, it is going to give us even function. Okay, and for example, if we have f1 of x times f2, for example, of x, and this one is even and this function is even, then the product is going to be another function of x, for example. It is even, must be even. Okay, this is like a rule. Okay, and a product of two odd functions is even. Also, if this function is odd and this function is odd, then the output is going to be even. Okay, and a product of an odd function with an even function is odd. It is going to be odd. If we have one odd function and the other one is even, then the output is going to be odd function. Okay, so we can clear and put it like this. If we have even times even, it would give us even function. Odd times odd, it would give us even function. And if we have even times odd function, it would give us odd function. So remember, this is like the rule of thumb regarding odd and even functions. Okay, so if f is even on this interval minus L to L, then the integration, the benefit now of odd and even is going to appear. Okay, the integration from minus L to L of this function, which is what? It is even function. Simply we can say it is twice the integration from 0 to L for this function. Okay, that's very easy and simple to understand even from the graph. Let's go back to the graph here. We want the integration of the entire even function. Simply we can say the entire integration, actually it is the area under the curve, right? We have the area here and we have the area here. As you can see here, this area equal to this area, right? So in our case, no need to have the integration across from minus L to L. It is enough for us to say that we are going to start from here, and this integration part, we're going to say that 2 times from 0 to L f of x is going to give us the same as from minus L to L of the same function. Okay, this is going to be our case here. So this is the fruit of knowing the even function in integration. So this is the part here. Okay, and if the function is odd on minus L to L, then okay, let's go to the graph here first. So we have like the integration here, the part of the integration here and here and here and here and so on. What do you think about this integration when we are going to take it from minus L to L? Exactly, it is going to be, yes, big zero, because whatever that you are doing here on the right, it is going to be subtracted on the left, right? So the summation of the integration is going to be 0, and this is exactly what we are going to have here. If the function is odd, this means that the integration of minus L to L of the function equal to 0. This is very beneficial. This is very beneficial. Okay, why? These facts that we have mentioned right now, these facts are sometimes useful in computing Fourier coefficients, right? Do you remember Fourier coefficients? This one and this one, an and bn, for example. Do you remember them? We have here f of x times cosine and f of x times sine. By default, cosine is even function. By default, sine is odd function, right? So if our function is even, then the integration is going to be 2 times from 0 to L of the function. But if our function is odd, okay, let's assume this is odd and this is even, so they are multiplied by one another, then it is going to be odd. So the integration is going to be what? 0. This means that this coefficient is going to be 0, right? So the benefit of knowing odd and even functions and their products is in calculation of the coefficients for Fourier series. It will greatly simplify our calculation, especially in terms of integration. Okay, so if f is even, only the cosine terms and possibly the constant term will appear in the Fourier series, because f of x sine x is odd and the integrals defining the sine coefficient will be 0. That's right. So we are not going to have, this is the sine coefficient, the sine coefficient here is bk, it is going to be 0 in this case. If this function is even, then even times odd, it is going to be odd, and then it is going to be 0. If the function is odd, then f of x cosine n pi x over L, which is here, this one, okay, is odd, and the Fourier series will contain only the sine terms. This means that this coefficient is going to vanish, and then based on this, this term is going to vanish, and we are going to have the sine terms only in the Fourier series. Since the integrals defining the constant term and the coefficients of the cosine terms will be 0, and this is very, very true. Okay, now this is the the understanding and the benefit of knowing the odd and even function. Now we are ready for having an example, and this is going to be in the next video. Thank you, and see you in the next